Okay, in our next proof, we'll see that the conjugate of a product is the product of conjugates. Kind of a similar proof, a little bit longer, but not terrible. So what we're looking to prove or show is that conjugate of the product ZW is worth Z conjugate by W conjugate. So similar definitions for Z and W as before. Z is A plus BI, and W is C plus DI. So ZW conjugate by substitution, conjugate of A plus BI by C plus DI. We can go ahead and FOIL that out. So we have AC plus ADI plus BCI plus BDI squared. And never draw that bar quite long enough. There we go. All right. So remember, I squared is worth -1. So this part is really a constant. So is this part. Oh, well, it's all constant. This part is a real number constant. These parts are imaginary number constants. So I'm going to go ahead and regroup them into the real number components. So that would be AC plus BDI squared, and the imaginary number components, AD plus BC, for each multiplied by I. So now that we have that format of real number plus real number times I, we can take the conjugate by just flipping the sign in the middle. So ZW conjugate, what was I? Finally remember to put that bar up there again. On the right hand side, we're not going to have the bar anymore since we're going to change the sign. So AC plus BDI squared minus AD plus BC times I. So we'll go ahead and, now that we've taken the conjugate, get rid of those parentheses. We have AC plus BDI squared minus ADI minus BCI. So notice that went to both terms. So then a little rearranging is in order. So I'll hang on to this AC and I'll just check them off as I use them. We'll move this minus ADI next to it. Then we'll use these two guys. So I'll use the minus BCI and the plus BDI squared. Okay, so 4 terms, we can do a little factoring by grouping. I can grab an A from the first 2 terms, leaving me C minus DI. I can grab a minus BI from the second 2 terms. If I factor a minus BI, I'm left with a C here. I'd have to flip the sign, so negative by negative flips me back positive. I factored a B, and I factored one of these 2 I's, so I have a DI left. And then we can factor one more time, so conjugate of ZW, A minus BI, by C minus DI. So we pulled that common factor, this time to the back of the line rather than the front. And then just by substitution, A minus BI, looking back up at the top, that is Z conjugate. C minus DI is W conjugate. That's what we're out to prove. So it might look a little strange, but again, the farther you go in math, you're going to see more and more proofs. It's the idea of not just can you apply the ideas, but do you know how things work. That's the main idea as you get a little bit farther in your math career. All right. Let's see, Another quick little mini review, this time of the powers of I. So I, we knew just the definition was considered the square root of -1. I squared, we said, is -1. Everything after that I can turn into combinations of these guys. So for example, I cubed is I squared times I, which is -1I, or you can just write it as -I. I to the fourth is I squared times I squared, which is -1 times -1, which is 1. So really this guy is kind of very handy. Everything bigger than that, you break it into as many I to the fourths as you can, then break into I squares and I's from there. So for example, if we're looking at I to the 61st power, biggest multiple of 4 that I can find near there is 60, so that's I to the 4th to the 15th. So there's the first 60 of them. I have one more left over. 1 to any power is a 1. 1 to the 15th is just 1. 1 times I is just I. I to the, let's say 43rd power. It's I to the 4th to the 10th. So there's 40 of them. I've got 3 left over, so I'll break it into 2 of them and 1 of them. So I have 1 times -1 times I. So I to the 43rd is -I. All right. So in the quadratics, last section I was more careful in picking out my examples because we hadn't hit the imaginaries and a review of that yet. So for solving something like x squared is -9, we can still use the square root. Still have to do the plus or minus on the side with the constant. And if I see a negative under a square root, that tells me we're into I territory. So then x is plus or minus, in this case, 3I. If we have, say, x squared minus 2x plus 7 equals 0, this one would be a little faster with completing the square. What's telling me that is that I already have the nice, neat, pretty implied leading coefficient of 1 there, and I have an even here. When those two conditions exist, completing the square is faster. Completing the square will always work. It just happens to be faster if we meet those two conditions. So x squared minus 2x is -7. Half of -2 is -1. -1 quantity squared is 1. So we will add 1 to both sides. So x minus 1 quantity squared is -6, and then square root method from there. So x minus 1 is plus or minus I root 6. You'll see authors sometimes write the I at the back of the line there. I like to emphasize for students that I itself is already under a square root. I is the square root of -1, so it's not under 2 square roots. And if you have handwriting that's terrible like mine, it's easy for this and this to look too much alike. So I tend to park that I out front. So then x is 1 plus or minus I root 6 would be our two solutions. Again, you can get there using quadratic formula. No problem there. We'll just run through it real quick just because some people prefer that way. So x squared minus 2x plus 7 equals 0 on quadratic formula. Opposite of -2, +2, plus or minus square root of -2 quantity squared is 4, minus 4 times 1 times 7, all over 2 times 1. So x is 2 plus or minus square root of, let's say, 4 minus 28 all over 2. Don't forget that 2 at the bottom. We can't have things disappearing and reappearing later on. So x is 2 plus or minus square root of negative 24 all over 2. Out of room there, so we will continue up here. So then x is 2 plus or minus square root of 4, square root of negative 1, square root of 6 all over 2. So x is 2 plus or minus 2I root 6 all over 2. And we can factor a 2 from the numerator. And 2 halves is 1. So then x is 1 plus or minus I root 6. So again, you get there eventually. It's just a little bit more work. So if you see this, leading coefficient 1, even there, completing square is quick and easy. Okay, so if you're doing the traditional book homework, this was section A7. I would try 1 to 89 every other odd, 93 to 96 all. If you're trying the online ones, I'll get those loaded up. All right. If you have any questions, please feel free to email me. Otherwise, I'll see you next time, and stay safe out there.